All right, so in this one we're going to be looking at how to find empirical formulas of different molecules through combustion of those molecules. So just a quick refresher here. Combustion reactions are when you have a hydrocarbon, so it's a certain number of carbon, hydrogen, sometimes oxygen, but not always. Also, sometimes you might have some nitrogen in there. But anyways, you're going to have that molecule combining with oxygen, O2, and that creates carbon dioxide and water. So basically what we're going to look at is you'd be given generally the mass of the molecule, and you know that when it completely burns into oxygen, you know how much carbon dioxide and water is formed. And from that, we can figure out what the equation is for that molecule, or the formula, I should say. So the way we do this is with ratios. We know that in carbon dioxide, when we end up with CO2, that of that CO2, a certain part of it is carbon, and that carbon comes from that original carbon over here. And that's a ratio of 12.01 to 44.01. That's the mass of carbon to the mass of carbon dioxide. Likewise with water, since there's two hydrogens, it's a mass of 2.02 for hydrogen to 18.02 for the water. And then oxygen can just be found by what's left over. And that's best shown with an example. Once you get the masses, you would be converting to moles. And then you, just like you did before with empirical formulas, you find the mole ratio between those values. So on the worksheet that I've posted, I'm going to go through the first number there. So you're given 1.50 grams of an unknown hydrocarbon, undergoes complete combustion and produces 4.4 grams of CO2 and 2.70 grams of water. Now, the total product here is more mass than we're starting with of the hydrocarbon. That's because it's combining with oxygen from the air. So we're going to start by looking at the CO2, and we've got 4.4 grams of CO2. We want to know how much carbon we have in there. So we just multiply by that ratio. So I'm going to times 12.01 grams of carbon per 44.01 grams of CO2. And that 4.4 times 12.01 over 44.01 gives us 1.20 grams of carbon. So we know that in that 1.5 gram sample that we started with, 1.2 grams of it was carbon. And we do the same thing with the water. We're going to multiply by the ratio of the hydrogen to the water. So that's that ratio from up here, 2.02 over 18.02. And that's going to give us 0.30 grams of hydrogen. Now to figure out if we have oxygen, we take the original amount, which we had, 1.50 grams. We're going to subtract the carbon. We're going to subtract the hydrogen. And that means there's nothing left over. That means there is no oxygen in that hydrocarbon. It's just carbon and hydrogen. If there was left over, then we would do the same thing that we're going to do next with that. So now we've got grams. We want to convert to moles. So you divide by the molar mass. And that gives us 0.100 moles of carbon. And this gives us 0.300 moles of hydrogen. And then you divide by the least amount. So 0.10 divided by 0.100. And you can probably see already what this is going to be. So it's a 1:3 ratio. So the empirical formula here is going to be CH3.